Math 1332, Chapter 3, Symbolic Logic, Section 2, Truth Tables. Video 3, Truth Table for Disjunction. This video is going to look almost exactly like the previous one, the Truth Table for Conjunction. So if you haven't watched it, I recommend watching it first. All I had to do was change the words conjunction to disjunction, change a few symbols, change a few trues and falses. So if you just got finished watching the previous video, this one's almost going to sound the same, but it's quite different. Recall that a disjunction is the word or, when used to connect two statements into a larger compound statement. The symbol for disjunction is a V. By the way, and I think I mentioned this in a video in the previous series, if you're having trouble remembering if this symbol is conjunction and this symbol is disjunction, it's easy to remember and or. The one that looks like an A stands for and, the other one is or. But if you have trouble remembering conjunction versus disjunction, one gimmick for remembering them is that the arrow for disjunction points down. Disjunction and down both start with D. All right. Let's see what's under here. To construct a truth table for disjunction, we start with a generic disjunction written symbolically, P or Q. Remember, disjunction is the symbol for or. Since the compound statement contains two simple statements, just P and Q, our truth table will start with one column for each. One column for P, one column for Q. The final column will just be for the disjunction. I don't know why I have the word just in there. By the way, in my head, every time I'm writing a disjunction, I think disjunction down. All right, so we got our columns set up, and just a reminder, in future videos, once we get past our rules, these tables will contain more columns between the ones at the beginning for the simple statements and the final column for the compound statement that we're finding the truth table for. Next, we populate the first two columns with every possible combination of truth values for P and Q. As I said in the previous video, I will always use the same order here. Either both of these statements are true, or P is true and Q is false, or P is false and Q is true, or they're both false. Technically speaking, these rows don't have to be in any particular order, but I will always start them the same way, especially because for the class I'm teaching right now, the homework that they're using, the homework platform, when they're asked to complete a truth table, the rows will always be in that order. All righty. Sorry for the long delay there prior to me pausing. Sounded like there was a dog in the room with me because I heard some noise, but there's no critter in here with me. Maybe my house is haunted. Anyway, to determine the truth value of the conjunction for each row, missed one of the disjunctions. Hold on. I knew it was bound to happen. To determine the truth value of the disjunction for each row, let's consider a specific case, and we'll consider the same specific case that we did in the previous video. We're going to let P be the statement I am female and Q be the statement I was born in Texas. So the compound statement is I am female or I was born in Texas, and we are going to do it row by row. And just to let you know, once we build our tools, we won't always reinvent each row at a time. We're just doing that to build our basic truth tables. First row. In the first row, both simple statements are true. So we're assuming that the statement I am female and I was born in Texas are both true. And we're asking ourselves, if the person who says the compound statement is female and was born in Texas, and yes, I meant to say and because we're looking at the situation where P is true and Q is true. If the person who says that statement is female and was born in Texas, is she saying a true or false statement? So picture somebody who is female and was born in Texas. Got somebody in mind? Okay. If that person says, I am female or I was born in Texas, is she saying a true statement? Now, this is where some people will freeze because they're thinking, well, she's female and she was born in Texas, but she said or. I am female or I was born in Texas. Is that a true statement? It boils down to whether or not the or is an inclusive or exclusive or. We had that discussion before, but to briefly remind you of the difference, inclusive or is when it's okay for both halves to be true. For example, if a selective college says you can come to our school, you must have a 1600, you must have a 1500 on the SAT or a 30 composite score on the ACT. If you have both, will they let you in? Of course they will. They didn't say this or that, but not both. But in other contexts, it's an exclusive or, which excludes the possibility of both. You're at a restaurant, today's special for $10, you can have steak or lobster. Yes, I'll take both. No, you can have steak or lobster, not either or, not both. That's an exclusive or. So there are contexts where or includes the possibility of both being true, and other situations where or excludes the possibility of being true. Just a reminder, in symbolic logic, the word or is an inclusive or, which means it's okay if both halves are true. So that being said, if the person who says this is both female and born in Texas, they are saying a true statement. There's the first row. Now, let's check out the second row. The second row has the first statement is true and the second one is false. So, true, false. Picture somebody who is female and was not born in Texas. I'm having a flashback to the previous video and wonder if I used Hillary Clinton in the correct row. I have to go back and watch it. All right. So, but let's say Hillary Clinton says this. She is female and she was not born in Texas. I'm pretty sure she's not born in Texas. If I'm wrong, I'm sure somebody will post in the comments below or send me a text if you have my cell phone number. But let's say that Hillary Clinton says a statement. Hillary Clinton says, I am female or I was born in Texas. Is she telling the truth? Well, she is female. She wasn't born in Texas, but she said or. She'd be telling the truth. I am female or I was born in Texas. Correct, you are female. She would be telling the truth. So in the second row, when the first statement is true and the second one is false, the disjunction is true. Let's go to the third row, shall we? The third row is when the first statement is false and the second one is true. So, picture somebody who is not female but was born in Texas. That's me. I am not female. I was born in Texas. If I say, I am female or I was born in Texas, am I telling the truth? Yes. Because even though I'm not female, I was born in Texas and I said the word or. That would be a true statement. So, when the first statement is false and the second one is true, the disjunction is true. Now, what about the last pair, if they're both false? If the person who says the compound statement is not female and was not born in Texas, should be a comma there. I know. I should have caught it in the previous video. If you're wondering why I always correct grammar and spelling, it's because grammar and spelling are really just grammatical logic, and I'm a very logical kind of guy. Plus, if you learn something besides math from these videos, all the better. But where were we? Oh yeah, both statements are false. I am female, false. I was born in Texas, false. Picture a person who is neither female nor born in Texas, such as Bill Clinton. And if Bill Clinton said, I am female or I was born in Texas, that's a very bad attempt at an impersonation, would he be telling the truth? And the answer is no. You said, I am female or I was born in Texas, but you're neither. And because you're neither, you told a fib. Your statement was false. Okay, something else disappeared. Must have been my imagination. So, when both halves of the disjunction are false, then the disjunction itself is false. And there we have our truth table. So based on the previous example, we have the following truth table for disjunction. This is something you should know. This is something you should understand. Now, if you want to commit it to memory, good luck. Because if you just try to memorize that collection of T's and F's without any rhyme or reason, it's going to be very easy to memorize it incorrectly. But if you want to memorize a table, that's fine. But instead, what I would do is I would focus on some rule that will help me remember that last column. Because remember, when your compound statement only has two simple statements, generically P and Q, the first two columns will always look the same. True, 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 false, false, true, false, false, preferably in that order. So really what we have to focus on in memorizing this is how this last column looks. So let's look at it and try to think about what it looks like and what it doesn't look like. Wow, that column is almost always true. There's only one time it's not, in the last row. So can you come up with a rule for the exception? The exception being it's false once, otherwise it's true. So what rule do you think we could say about a disjunction being false? A disjunction is false if and only if all of its simple statements are false. If you want to memorize the table, go for it. But know this. A disjunction is false if and only if all of its simple statements are false. And just like we said with conjunctions, this holds for more than two simple statements. For example, P or Q or R is false if and only if all of them are false. So that means no matter how many statements you connect together with or, your statement will be true unless every single statement you say is false. So I'm about to say a statement that will eventually be true. Listen closely. My name is Eric, or I am female, or I am 21 years old, or I don't wear glasses, or I have 19 toes, or I have 10 fingers. That statement was false until I got to the very end. So I can say confidently that the entire statement is true. I know all the stuff at the beginning was false, but in an or statement, no matter how long it is, the only time it's false is when every piece of it is false. If even one little piece of it is true, then the statement is true. It's almost the complete opposite for conjunction. Remember that the rule for conjunction from the previous video is it's true only if all of it is true. For a disjunction, it's false only if all of it is false. So memorize the table if you want to, but know that rule. A disjunction is false if and only if all of its simple statements are false.